So what do you want to reconstruct when you say you're going to reconstruct an old growth forest? What do you need to know? What is it that you're going to do with that information? It's nice to see at least there's a couple copies of the poem out.
So we want to calculate the total biomass of the free log stand that was there in the soil duct, and then calculate carbon sequestration from that.
Okay. So what two things are you going to compare?
Probably height and diameter.
What did you just tell me that you wanted to calculate?
The biomass.
The biomass, which you can turn
Volume
into
biomass.
carbon.
Mm-hmm.
Biomass when?
Previous.
Previously, and what else?
And
the
the
future.
dominant.
In biomass when? It's very explicit what you're asked to compare. I think it's explicit. Thought it was when I wrote it.
So free log stand.
Yeah, so old growth and second growth, right? What's there today? What was there before? Okay. It's not too complex an idea? What is this?
Old growth.
Old growth.
So this is what it used to look like, basically. And you're going to be able to figure out what's growing there now, right? You've done that before? Now, so the only information you have at the soil duct about how it used to look is what?
The stumps.
The stumps, right? Because all the other stuff's gone. There's no sign of it. All the small trees that were cut down, there's no sign of those anymore. Those stumps decomposed a long time ago. But the old growth stumps, they're there. You may have recalled that you saw some of those out there. You'll see them when we go into the DNR stand. If you look right and left, you'll see stumps. You'll see that they're spread out. There aren't a lot of them. I mean, there's been places here you saw a lot of big trees, but there's places here you haven't seen any big trees, right? What sticks in your mind was when you saw the big trees. What didn't stick in your mind was that most of the time you weren't seeing big trees. Imagine we did an experiment coming in and you stopped every 100 feet and you looked 10 feet to your right and 10 feet to your left and you recorded if there was a old growth tree. What do you think your count would be at the end of the day?
Not very large.
Not very large, right? So keep that in mind, right? We see what we look for. Trails go where? Where the big trees are, because what do people want to see? They want to see the big trees. So by walking on the trail, because they want to see the big trees, then they see a lot of big trees, they're convinced the forest is full of big trees. But we don't want to do that, right? We want to know what things are really like. All right, so you've got the soil duct, what it looks now. You can figure out what the big trees look like. Can't you get the diameters off the stumps?
Yeah.
There'll be an underestimate because the bark's gone, right? So it'll have a lower bias to it. Can you figure out how tall those trees were?
Can't we use that by using site index?
Can't you use the site index? Weren't those big old trees?
Yeah.
Doesn't that mean they reached their maximum height?
Most likely.
Most likely. And if you take a look, once they get old, they don't grow very much vertically, right? It slows way, way, way down. And if you did a couple CBTS estimates, you're going to find out it doesn't make much difference at that point. Most of the biomass is already there.
So,
Yes.
if we're looking at, we just have the age, and then we'll have the site class from this forest we're surveying.
Well, we know what it is here. It's site class 1. You can estimate what it is in the soil duct, right? You've already done that. Right? It's site class 3, as I recall. If you did it correctly, it's a site class 3 forest. So you can figure out what it was then by what it is now. Site class is site class. One of the really important things is, despite what some people claim, cutting down trees does not reduce the growth trajectory of the next generation of trees. It just doesn't affect them. I know there's that disinformation, and we know who spreads that disinformation, but it's false. That's one of the first questions I asked when I started studying forest ecology. Well, gee, what is Weyerhaeuser doing to the productivity of its forests? Answer, nothing. Well, you mean it's not in the data that the trees are slowing down? No, the data doesn't show that. Now there's lots of long-term studies that show the same thing. Even when you remove everything, trees grow fine. They don't rely on this surface soil because where are their roots?
Way below.
They're way down. They get their nutrients out of parent materials. They're not using this detritus pathway. The hardwoods do. But that's not what our old growth trees are. They're not hardwoods, right? They're conifers. Those are the big giant monster trees. So site index today is what the site index was before. So what you don't know what was out in the soil duct was what the understory looked like. Do you know what the understory looks like here?
Yeah.
Can you get a number for it?
Yeah. Like a percentage.
Well, what do you mean when you say a percentage?
Never mind. I'm thinking ground cover.
Okay. Well, how have you measured volume of trees? Well, how do you get the number? What do you need?
Diameter.
Diameter and
Height.
height. Is that what you need? All right. And here, right, this is when we get to where the Douglas fir is, and we better use that because that's what soil duct was. I mean, I wish we had a mirrored forest, but we don't, especially given I wanted to be in the South Fork today. But you need to figure out what the understory looks like over there, right? How many trees per acre? What's their diameter? Probably it's going to be the same species mix, right?
Uh-huh.
Wow. That shouldn't be growing now. I'm sorry, I got distracted. Does anybody see what's behind Jared and Maya? Where's it growing? You can see why I got distracted. It's not supposed to be there. But it is. Wow.
Right?
There was a gap here and it got enough light and it's made it. So isn't that wild? All right, where was I? So you can get that data here, can't you? Now I brought the laser rangefinder to make it easy to get the heights.
So that we don't have to do it.
Thank you.
I do it for all my classes, so you weren't special on this one.
Well, you could let us feel special.
Yeah, you don't have to tell us.
Yeah.
No,
Don't
he
tell
wouldn't
us.
let us feel special. It's okay.
You want me to lie to you?
Yes.
It's not lying if you don't mention it.
Only about that.
Only about that. Okay.
So, I have a question.
Yeah.
Because there are less big trees, the big trees here are spaced out more.
They're going to be spaced out in the soil duct too.
Right, okay, but because big trees are spaced out, then our 20th of an acre sample plots, are those not going to be big enough then?
Tomorrow, no.
Okay.
Absolutely not. Remember, when you have heterogeneity, you need bigger sample plots.
Okay.
And we generally do it with 1/10 of an acre, but it's really spotty because they're too small. You've been using a 20. If you go, 1/10 is twice as big. It doesn't work real well. I think we're going to try something bigger for this last time to see how it. Sometimes it works fine. Sometimes it doesn't because it's random sampling. But let's start with 1/10 of an acre plot out here, just so you can get used to working with something that's a little bit different. So you need to go out 36.6 feet, I believe, will give you 1/10 of an acre. I think what we want to do is we can work with 1 or 2 groups. I brought a lot of D-tape, so we can get data pretty darn fast out there, I think. And probably, so how many D-tapes do we have? How many people have D-tapes? So 1, 2, 3, 4, 5, 6. That's,
3 per team. Us group.
oh, so you have 1 D-tape.
Yeah.
You have a D-tape.
And then I have one and she has one. All 3 of us right here have D-tapes.
No, I don't.
Oh, you don't have D-tapes?
I have one.
She has.
And you have 1. Okay, because I handed out 2, and then I thought you had 4. Well, we have what we have, so it looks like you've got 5 D-tapes. Okay, so you can have 5 people measuring diameter. You can have more than 1 person taking notes, right? So that person could be walking with a person that has a D-tape, or with 2 D-tapes, so you can move quickly. A couple people can be establishing the perimeter. So can you see how, if you got some specialization and people moving fast, how quickly you can acquire that data? Right, so the person's literally running out the tape in a cardinal direction,
Yeah.
cloth tape. What can diameter measurers be doing? Moving with them, right? So you can have one cloth tape going in one direction, the other cloth tape going in the other direction. Come back in, go the other direction. I'll shoot you some heights on just some representative trees. That's all you're going to need because you're going to discover something pretty quickly about the biomass when you start calculating it. Okay?
So
Go ahead.
I just want to confirm because I want to wrap this around in my mind.
Yeah.
So we are taking data from this site and we are comparing that to the soil duct of how this place was before.
The
how
assumption
sold
you're
out.
going to be making is that the understory here is representative of what the understory there looked like.
Okay.
That's your assumption. How can you test your assumption? You can find old photographs from the logging. I mean, I haven't done it, but you could do that, right? To see like, it's close. But what you're going to find from your volume calculations is your assumption's going to be fine.
Okay.
And you'll see that if you do your analysis right, you will see that. And that's all I'm going to tell you. You're going to see that. You'll make that connection. I want you to make some connections on your own. I want you to have those aha moments. And you might not make them. Some groups make it, some people don't. If you do, you'll discover something really, really, really important. But I will have graded them before our last day of class, and I will emphasize what that lesson is for carbon management. So it really kind of goes to what, concern about climate change, what's the role of our forests. Like most things with me, you'll find that my answer is not going to be we should be doing one thing with our forests. We should be doing lots of different things with our forests for lots of different reasons. But that's purely valuational. I mean, that's my value system. I'll try to always be honest about that stuff.
When are you gonna go over the first poem and tell us how, like,
Probably after the final.
after the final?
No practicum. All right, are we set so far with experimental design? One more thing on experimental design, we need to decide how you're going to find your plot centers, right?
So do we want more? How many plots do we want? Do we
That's the
want, like,
last
3
thing. So
plots?
what do you need for a sample size?
Well, we need 1/10 of an acre.
Sample size, not plot size, sample size,
Like
N.
3 plots?
I'd say
I
as
think-
much as possible. So
I think
I'd say at least
5
6.
or 6.
Yeah, I think 6 would be the minimum if we're gonna measure the dynamics.
That'd be
Each
3
team could
plots
do
per
3.
team if we're divided into 2 teams.
Should we do
Or is
12
it-
then?
Well, you don't have time.
We don't have
Yeah.
What have you learned about your T statistics? What have you learned about your T statistics? And keep in mind, you only have so much sampling for tomorrow too.
That's the smaller statistic you have, the greater you have for variability.
Larger
Well,
conference.
how big
your
did
larger
N have to
confidence
get
interval.
before the gains in your T value got relatively small?
At least 4.
And then they started not changing very much, did they? Remember that?
Let's do 4. 2 each.
I thought we were going to work in one group so I can shoot
one
heights for you because I can only
right,
work with
okay.
one group.
All right.
That's fine.
And I'm stuck. I mean, that's just the limitation there. I think you'll be fine with a sample of 4 or 5. I really do. I think